Hello everyone, my name is Rupali Sabnis and I'm engineer with Watershed Protection Department at City of Austin. And today I'm going to present a flood risk reduction project titled Warren Street. This is going to be the outline for today's presentation. I will talk about the background, about the flooding background, what is a flooding. Then I will give some introduction about the project itself. Then I will talk about the preliminary engineering phase. That's the phase this project currently is in. Then I will share some preliminary model results with you. And the most important part of this presentation is I'll go over how you can be part of this project and provide your feedback to us. So what is flooding? There are two types of flooding. One is called creek flooding and the other one is called localized flooding. As shown in the bottom right corner picture, that shows a picture of creek flooding. This is taken here in Austin. This occurs when a creek rises over its banks. So this kind of flooding occurs along the creeks or open channels when their capacity is exceeded in a storm event. And this is the most common type of flooding people are familiar with. The other type of flooding is called localized flooding, as shown in the top left corner picture. This kind of flooding occurs away from the creek. So as you can see in the picture, this area is miles away from any kind of channel or creek. And the main reason for this kind of flooding is inadequate or lack of a storm drain system to convey the runoff after a storm to the creek. And this is the kind of flooding we are seeing in the Warren Street area. So this is a general picture of what kind of localized flooding we see in the city of Austin. All the dots in the right side picture you can see, those represent a complaint, a flooding complaint that is in our database. All the red dots represent building complaints, and by that it means that the water, when the flooding occurred, either entered the garage or actually the house or the building. The yellow dot represent yard flooding complaint, which is basically the water entered or water got ponded in the yard but never entered the building. And the green dots, they represent the street flooding complaint, which as the name explains, the flooding occurred on the street and did not enter the property or the yard or the building. The typical trend we see is the neighborhoods that are built before 1980s. So that is before the current rules were in place. They tend to have more drainage problems. And the blue area that is shown on the map called as project location is where the Warren Street, this project is located. And just looking at the extent of the problem that we have in the entire city, it often requires large capital improvement projects or the large projects to address these problems. And these projects need a lot of time and money to fix the flooding. So these are the typical phases of a capital improvement project, and I'm just gonna go through so you know this particular project, what all phases it will go through. So the first phase of the project is in-house feasibility. This is when a project or an area is identified to have a flooding problem. We study it internally and look at if there are any feasible options that can be implemented there. Once we see some capability of having some feasible options, it is taken to what is called as preliminary engineering study, and that's where this project currently is. During the preliminary engineering study, different options and different options or alternatives are looked at to see what improvements can be done in the area to alleviate the flooding in the area. And end of the preliminary engineering study comes out an option or alternative that can help reduce the risk of flooding and which is constructible. Once we have that option, it goes to the design phase where the components of the solution are looked at in detail from the constructability point of view, and they are designed. Then it goes to the permitting and bidding when the contract is awarded to a contractor to actually do the construction of the project, which is the last phase of this cycle. So as I mentioned, this project is currently in the preliminary engineering phase. So just talking a little bit about the project itself, you can see in the map on the left side, the boundary shows the general project boundary. That does not mean that there will be improvement on each and every property or street in this boundary. The location and everything depends on what solution comes out of this study. All the dots, as I told earlier, represent the flooding complaint, with red being the building, yellow yard, and green street flooding complaints. There are total 17 complaints in this area, and there are 14 building, 1 yard, and 2 street flooding complaint, and it is a high ranked priority area on our list. The system currently that's there, the storm drain or the open channel, it was built around 1950. So you can see it's pretty old system and does not have the capacity to actually convey the water or the flow that is generated here. And the main cause of flooding, as I just explained, seems like the inadequate storm drain infrastructure. So just now I'm going to talk about the PER phase, the preliminary engineering phase for this project in particular. So what all happens in this phase? So the first step in this phase is to collect the data. So collecting historical rainfall data, LiDAR is the terrain data or the ground data, carrying out field visits and actually ground surveys to gather more data, looking at high flood water marks to get, how the flooding is occurring or has occurred in the past. Then the second step, once we get all the data we need, is to create the existing model. It's very important before we design any kind of solution, to know what is actually happening right now in the area. We do have flooding complaints on the record. However, that does not necessarily speak about all the flooding that is occurring in the area. So we do the initial existing model and see where the flooding problem is, and that helps us design the alternatives. So what do we look at in this existing model? How much water? How much water are we talking about that's still remaining on the ground and ponding and causing flooding? Then how high the water gets? So that means the depth of water, at different locations within the project area. And the technical term for that is hydraulics. The technical term for how much water, the quantity of water, is hydrology. And the third important thing is where the flooding is occurring or where the ponding is occurring. And that tells us the extent and the severity of flooding. All these three things are very important for the next step, which is to develop the alternatives. We look at different alignments, where the pipe should go, where the inlets should go, where the open channels can be constructed, and what are the sizes of all of these to convey the water. It is very important for us to make sure that in effort to fix a problem in one area, we are not causing an impact to some other area downstream. So we make sure our projects do not cause any adverse impact to any other properties as well as environment. More often, we try our project to have this infrastructure within the right-of-way or within the existing easements that we have. However, sometimes that doesn't remain the most feasible option, and we may need to acquire more easement to build our infrastructure. And just briefly, what an easement is, it is the part of property where the city has limited rights of access and use, and land is still owned by the property owner. We really do not have any idea, particularly for this project, if we need to acquire easement and how they would look like. that we will get a better idea end of this phase. So let's move on to some preliminary modeling results. So we perform a two-dimensional engineering model for this. So the models are the computer programs which simulate the flow of water in the storm drain system as well as ground. So in the two-dimensional modeling, as they say two-dimensional, it simulate the flow that is in the underground storm drain system as well as the flow that is on the ground at the same time. And that's why it's very important that way, because we want to know how the system looks, but at the same time we are also want to know how the water is behaving on the surface, where it is ponding and causing flooding. So the map on the left is showing the result of the depth of water on the ground surface for a 100-year storm. So the 100-year storm is 1% annual chance storm, and different colors or shades of blue are representing different depths as shown in the legend on the right bottom of the map. So the darker the shade of the blue, the deeper the water is, and the lighter, the less deep the water is. And the dots that are in the map are showing the complaints, the flooding complaints in the area. Now, to give a little better representation or understanding of how the flooding occurs, I'm going to show a video of this model. It is again, the preliminary model. It is also for the 100-year storm event. And it is going to show, once the rain starts falling on the surface, how the water flows in the area on the ground surface and where it is ponding, and how it is deep it is ponding. One thing to notice that once the video starts, the lighter shades of blue represent the lowest depth of flooding that is on the surface, and as you can see in the right side legend, the blue, the green, the yellow, orange, and red, in that sequence the depth of water is higher and higher. Also, if you can imagine, once the rain starts, the water starts slowly ponding, and then once the storm passes by, the water that is ponded slowly resides. So you will see all of that here in this video. So you can see that slowly the water is starting to pond in the open channel that is in the area, and some other locations or low spots. And as the storm intensifies and more and more water drains down the hill, the depth of water is increasing as well as more ponding is seen. And this is kind of the peak of the storm or peak of the flooding. As the storm passes, the flooding or the flooded water or the ponded water just resides down. So the most important part of this presentation, we need your help, your input to design this project. We do have some information in form of flooding complaints with us, but you all are ears and eyes for us to tell us what exactly happens in your area as far as the flooding goes. And unless we know what exactly is happening, we won't be able to design an effective project to meet the needs of the area. So please help us provide your feedback on your experience with the flooding. What kind of feedback we are looking at is, you just saw a video as well as the map. So looking at that, does it show what you see in your area? Does that map or video matches what you see in your area? Does it show any difference? So does it show water ponding somewhere where the map or the model is not showing? We would really like to know about that. Please share your experience in the form of photos, videos, just the email, text, whatever information you have will be very valuable for us to make this project success. And how you can provide the feedback is visit the website that is here, austintexas.gov/Warren, and you can click on the flooding information form link that is on that website and fill in as much information as you can. Alternatively, you can just email all the information you have to this email account, floodpro_stormdrain@austintexas.gov. So please help us know what you see in your area for the flooding. Lastly, I just wanted to share some of the resources that we have for the flooding. So we consider purchasing the flood insurance, even if you are not in the floodplain or even if you have not flooded before. I think it's a good thing to have. If you ever see a flooding or experience a flooding or have any concerns about the drainage, please call 311. There is also a telephone app that you can use to lodge a complaint. We do look at all the complaints that we get from 311 and try to address those. So please, I'll encourage you all to do that. Avoid building in drainage easements or floodplains. If you have any more questions about the flood proofing, please email us at floodpro@austintexas.gov, or you can also check the atxfloodsafety.com for additional resources. And that concludes the presentation. If you have any questions, any comments, any suggestions, please reach out to anyone on the screen. We have shared our email address as well as our direct telephone line. So please share, ask questions, any questions that you may have. So that's it for today's presentation. This is Rupali Subnis. I'm signing off from the presentation. Thank you so much for your time and have a good day.